This is a question. You can do it also. You have to prove that P01 is mu01, this transition intensity, because we had in CT5 mu only, here mu01, mu02, from active, retired, dead, two are there, okay, mu01, mu02. So even this kind of a formula we already used in CT1, CT5, that is a part of CM1 now. P01, mu0, from mu01 we can get P01, from mu02 we can get P02 using Kolmogorov equation, okay.
So one question please.
Yeah,
Is
tell me.
P01 and P02 here refers to the probability,
Yeah, probability.
the ones that go into the transition matrix?
Yes,
Okay.
always. When you
Yes.
use Kolmogorov's equation,
Mhm.
always you get transition probability matrices. Okay, like when we say this chapter, discrete time, continuous time, discrete time, we always connect these mu ij, Pij when you get through Kolmogorov equation. So always. Only thing, jump chain matrix I discussed today. So the jump chain matrix we consider when we consider this one. I'll show you another result here. This one, probability that the process goes to state J when it leaves I. So when it leaves I, when I say, we are not seeing after a particular duration. Suppose I am giving a class now, it's a continuous time process, I am continuously giving you class. Suppose someone comes and sees after every 5 minutes whether I am changing the state or not. So after 5 minutes I am in the same state, after another 5 minutes I am in the same state. If you are checking this way, then these are transition probability transition probabilities, and they will go to transition probability matrix. However, my rate, someone wants to estimate my rates of changing my state from this state to other state, then we'll see a small time. In small time what is happening, that's what we'll find. But when we talk about jump chain, if I leave this state, whenever I leave, suppose the time is not fixed, randomly I called you and randomly I will take, even you don't know whether it will be 15 minutes or 30 minutes or 35 or 1 hour, 1.5 hour, you don't have any idea. Then what will happen is, when I leave this state, where I will go, suppose I will go to watch movies, or I will go outside, or I will go somewhere, I have to find all probabilities. If I leave this state, what is the probability that I will go to see a movie? That probability is suppose 80%. That probability is different from the probabilities someone checks after each 5 minutes. So when you check something after a time interval, after 5 minutes, then these are the normal small Pij's, the probability, the transition probabilities. Remember, in transition probability, always we see something after a fixed time interval. This day, today, tomorrow, this week, next week, this year, next year. The problems we solve maybe a week or 15 days before. Now we are considering continuous time. In between we have something which is called this one, these probabilities. Once the state changes, then only you have to watch. You will not watch after each time period. See, what will happen is, suppose you write after each 5 minutes, okay, this is 5 minutes, 0, 5, 10, 15, that way. So when you watch this, okay, from here where I will go after 5 minutes, after 10 minutes, after 15, you are watching this way. If you watch only when I change a state, okay, suppose next time I am here, then we watch here, right? Suppose I am here, then also we watch and we record this one. Suppose I am here, we watch all this, okay, this one. So you have to only say here where I am after a particular duration. But here in jump chain matrix we don't do that. What we do is, I will not write 5. I will write only when there is a state change. Suppose I am here, okay, the state is changed now. So this is waiting time. After this waiting time, the state is changed. So I will not record this. I will record only this state and this time. This is waiting time, T0, 16. That that probability. What is the probability that when I leave this one I will go here? That probability we are finding using this. This is capital Pij, and from this only I got this mu ij, that is capital Pij, which are not these are small Pijs, and if you cross multiply you will get lambda I, sorry. This equation I use from this one only. So these are the jump chain probabilities. They have link with waiting time and waiting time distribution, because this is the waiting time concept link, as link with this one. Whenever there is a state change, then only you are supposed to observe. If someone is sitting outside and someone will go and inform, if I change the state, normally we watch the kids, they are studying, okay, and my duty is to watch whether that kid is studying or he changed to some other state, he is watching mobile or TV. So I have to go and report the teacher only when the kid changes his state. But otherwise somebody says, no, you just tell me after each 5 minutes you change where he is. So after each 5 minutes I will send a message. I will send that, okay, he is studying. After 5 minutes, suppose now he is watching a movie, okay, or watching television, TV. Now he has no idea, he will not be able to know when he changed, exactly when he changed. He will only know that, okay, at this time 7:30 he is watching TV. This one. After a fixed time duration, we are recording where he is, but here only when I am supposed to report, only when he changes the state, not here, not here, not here, not here, here only once. This, and even I am not interested in the waiting time. Once he will change the state, where he will go and what is the probability that he will go here, okay, this is what we find, Pij. Now, yeah, this is a problem. You can form a forward differential equation and you can solve it. It's very easy. And these kind of problems will come, you are supposed to do. I can write the forward differential equation and then you will be able to solve it. It's not a problem, okay? But I think you will be able to do that. I will write only equations, then you will be able to solve these. So let me write here only. I want P0 1, okay, so let me write here del upon del t or d upon dt P0 1 t. Also remember we are interested in 0 1 t, okay. If you see here, this is given this way because this is linked with CT5, that is part of CM1. Now age is also important. What is the probability that if someone is 50 now, okay, what is the probability that by 51 he would have died, okay? This probability you have to find. This is rate, this is not probability, this is the probability. Because age is involved here, this probability will not be equal to this probability. That's why here there is a mention of x, and that's why I was forced to write del, because keeping x constant we are finding this. How can you say x is constant? Because if you see the rates are not functions of x here. Considering that, assuming that the rates are not dependent on age, we are doing this problem, okay. So we change del d to del, otherwise you can write d by dt also. This x has no use at all, only it appears in the symbol. But basically what we do is we need to find P01t in this problem as well. It's not a new problem, okay. So we'll write the equation, and when you solve this one you will get the answer. This is very easy. Okay, in this equation P00 will come, but we will not worry about that. So let me write this. P00T, this is the only option here. You see the diagram, this is the only option. 0 to 1, I will write 0 to 0, 0 to 1, that's all. And what is P00T? That is P00 bar T, because once you leave 0, there is no way you can come back. Okay, so staying continuously in 0 before leaving 0 is equivalent to all the ways coming back also. Okay, that's why they are equal. And we have a formula for this one, that is e power. Remember now, when you find 0 0, the formula says from 0 whatever number of arrows are going out, those probabilities you have to write here. Okay, so I will write only mu 0 1. I will write only mu 0 1. Okay, because from 0, okay, we have this one also, both are going out, so I have to add mu 0 2 dt. I will write, I will integrate. Okay, and once I integrate, I will get this one. This is constant dt integration t anyway, so this will be finally this. So let me write here e minus mu 0 1 plus mu 0 2 dt integration t. Okay, t into mu 0 1, that is dy. Y I have taken for this one. Okay, dy by dt. I have to solve this one, that's all. When you solve this equation directly, you can solve, right? Because this is a constant. Okay, and this is a constant. You just need to integrate e power lambda t, e power minus lambda t divided by minus lambda, that's all. And when you use initial condition, you will be able to find the constant, you will get this one. It's very easy. Okay, it's a 2-line problem, you can solve it. If you want, I can do also here. Dy upon dt, that is equal to this one. I have taken P01T. Okay, we don't have P01 also. No, y is coming to right hand side, that's why it's easy. So e minus lambda t, let me write it, this is k. Then I have to solve this one. Dy will be equal to k e minus lambda t dt. Integrate, take a limit or directly integrate, and you write a constant k e minus lambda t divided by minus lambda plus constant. And if you remember, this was P01T is equal to this. Okay, so you take this here 0, so T0, if you put T0, you get k divided by minus lambda e power 0 1 plus c. So P0 to 1, what is the probability that you will go from 0 to 1 in time 0? This is 0, so c will be minus k divided by lambda. Okay, so replace c by minus k by lambda. Minus, yes, minus comes here. So now you take k upon lambda, you will get e power minus lambda t minus 1. Okay, that is y is P01T, so we missed minus here. Okay, we'll see what is lambda. Let's see what is lambda. Minus mu 01 plus mu 02. Okay, and what is k? K is mu 01. So y will write P01T, lambda is minus mu 01 plus mu 02, k is mu 01, and that minus will multiply here, it will be 1 minus lambda t. That's all. This so easy. Okay, so this you can solve. Similarly, you form equation for the other one. Suppose I form equation del by del t P02T. 0 1 is over. Now form differential equation for 0 to 2. This one. 0 to 2, see, when I say 0 to 1, only 0 to 1, but 0 to 2, okay, 1 to 2 also there is no connection here, right? So they are similar, right? Because there is no connection to 1 to 2, okay, sometimes we will have connection this way, then that also have to consider. When you go 0 to 1, 0 to 0, 0 to 1 you will write 0 to, if this is 2, okay, normal this is 2, suppose this is 2, this is 1, you will get a question like this. There is arrow here also, and 0 to 2 when you find, how you find 0 to 1, 1 to 2, 0 to 0, 0 to 2, 0 to 2, 2 to 2. So all these you have to consider. So that will come with experience, okay. When you do a lot of problems, you will have no doubt. But this is very simple. There is no connection here, so there is no difference also. Whatever way you do, the same way you can do this one, and you will get the second one, okay. They look quite similar. Now the last thing is this one, okay. This is the last topic of today's class.